Welcome to today's presentation on the Titus HEPA Room Air Cleaner. Your presenter today is Ken Loudermilk. Ken is the Senior Chief Engineer at Titus, and he has over 40 years of experience educating and assisting engineers in the design of innovative HVAC technologies. Ken is a frequent speaker at local and national ASHRAE events and has co-authored numerous industry publications. Now let's begin the webinar.
Hello everyone, this is Ken Loudermilk, Senior Chief Engineer at Titus, with some exciting news regarding our portable room purifiers for healthcare applications. Collectively, we've done a ton of research on the application as well as how we stack up against the competition, and I would like to share some of that information with you today. This presentation is recorded, so you'll be able to review it at any time. At the end of the presentation, we'll entertain any questions or comments you might have today. Of course, you can also forward any questions you might have to myself or Matt McLaren at any time. We're happy to introduce the Titus THRC line of HEPA-filtered portable air cleaners. These units are of the highest quality construction and designed specifically for use in hospital and other healthcare facilities. The THRC units are portable and can be easily moved from one room to another. They're designed to create a clean environment during pandemic times and can be configured as an air scrubber or an exhaust filtration unit that enables the temporary conversion of a general patient room to an AII room. THRC units contain a HEPA filter rated at 99.99% efficiency in removing 0.3 micron particles. The units also contain a MERV 8 pre-filter, which lessens the particulate loading on the HEPA filter and thus extends its useful life. An air pressure sensor within the unit illuminates a pilot light to indicate when the HEPA filter needs to be changed. THRC units are significantly quieter than those of our competition and require little maintenance other than filter changeouts. The THRC high flow unit, shown here, incorporates a 3-speed switch to deliver up to 800 CFM through its HEPA filter. The THRC low flow unit is pictured here. Its motor speed can be manually adjusted to deliver anywhere from 70 to 400 CFM. Again, that airflow is either recirculated back into the room or exhausted from it. The low flow unit incorporates all of the other features mentioned on the high flow unit. THRC units are designed to operate in 3 distinct configurations: full recirculation, full exhaust, or partial exhaust. THRC units operating in their full recirculation mode serve as air scrubbers and significantly reduce pathogen concentrations in the spaces they serve, reducing the risk of airborne disease spread to both staff and visitors. Room air is drawn through a return inlet in the lower part of the unit's face. Cleansed air is then returned to the room through an egg crate type grill located within the slope top face of the unit. Units operating in full exhaust mode clean the air within the space prior to removing it. There is no recirculation of the cleansed air back into the room. Instead, it is exhausted through a wall, window, or into the room's exhaust duct. Operation in this mode requires replacing the grill in the top panel of the unit with a plate that contains a nominal 8-inch diameter duct connection collar. This plate is sold separately. THRC units operating in a partial exhaust mode recirculate half of the cleansed air back into the space while exhausting the other half. A 6-inch duct collar furnished with the unit replaces a blank-off panel on top of the unit to allow a flexible duct connection to the room exhaust system. Partial exhaust, where allowed, reduces the energy waste involved with direct exhaust to the outdoors while reintroducing cleansed air back into the space. This slide details the dimensional information for the two models. Note that the depth of the units is only 15 3/4 inches, and they can be located right against a wall since both the intake and discharge is accomplished through the face of the unit. Also note that they can be furnished with an optional UVGI light. We will discuss that in more detail later in the presentation. This slide details the airflow capacities, electrical specifications, and unit weights of the two models. The low current draw of the THRC units enables them to plug directly into existing 15 amp circuits. Other options that are available include upgrade to an ULPA filter with an increased efficiency of 99.999%, upgrade to a carbon pre-filter, and a discharge panel replacement that incorporates an 8-inch diameter collar for connecting to flexible duct when the units are applied for full exhaust. The UVGI light is an attractive option that has been well thought out. It is located upstream of the HEPA filter, which allows it to kill viral particles that have been trapped on the inlet surface of the filter. Although HEPA filter changeouts and handling should still be performed in a safely prescribed manner, doing so is less likely to result in disease transmission to service personnel. The HEPA filter also shields the motor and its wiring from exposure to UVC rays that can damage plastic and rubber components. As you can see, the front panel of the unit is removable for servicing the filters and the UVGI bulb. Let's look at how HEPA and ULPA filters work. Particles passing through the filter can be captured in three basic ways. Large particles are strained upon encounter with the filter. Smaller particles that pass through the face are captured by impact with other fibers. Or very small particles diffuse randomly through the filter media, which increases their likelihood of impacting on a fiber and being captured. While HEPA filters are rated for their ability to capture 0.3 micron particles, they're even more effective at capturing larger or smaller ones. Although the nuclei associated with COVID-19 is typically only about 1/10 of a micron in diameter, they are efficiently captured by the diffusion process. These are the ASHRAE and CDC guidelines for air change rates that are effective against viruses. Note that the recommendation suggests that all spaces should be subjected to an equivalent air change rate of at least 6 air changes per hour, with isolation rooms and certain other inpatient spaces subject to twice that. Although ASHRAE Standard 170, ventilation of healthcare facilities, does not require that general patient rooms be maintained at a negative pressure with respect to their surrounding spaces, doing so is a good idea during pandemic times like we are facing with COVID-19. This slide relates air change rates to room volume. The room volume is calculated by multiplying the room floor area times its ceiling height. The table also identifies the time in minutes that would be required to remove 99.9% of the room contaminants at each air change rate, assuming no additional contaminants are introduced during this period. A similar recirculated airflow rate passing through a 99.9% HEPA filter will accomplish the cleansing about 7 times faster. Now let's talk a little about the applications these products are intended to serve. The units are specifically designed for use in healthcare facilities. This includes both inpatient and outpatient facilities. As the units are portable, we will limit our discussion to adding them to existing spaces in order to upgrade their configuration or enhance the removal of viral aerosols. The ventilation and filtration requirement for various spaces in healthcare facilities are currently governed by ASHRAE Standard 170, 2017. For a standard hospital patient room, a minimum of 4 total air changes must be delivered to the space. although it should be noted that facilities designed before 2013 required a minimum of 6 air changes. These air changes can be either ducted or contributed by recirculation of air within the individual space. At least 2 of those air changes must be ducted outside air. All of the air supplied to the space must be passed through a MER 14 filter before entering the space. When operating in this mode, recirculation through the THRC HEPA filter removes 99.99% of pathogens before returning the cleansed air to the space. The unit would ideally be placed directly across the room from the patient's bed and would deliver clean air back over the patient. This would also result in significantly reduced pathogen contamination levels in the air exhausted from the room, reducing the possibility that these pathogens could be recirculated to other spaces served by the air handling unit. This table relates the capacities of the THRC units for providing various air change rates to varying room sizes. It is likely that a patient room's volume would be between 2,000 and 3,500 cubic feet. Note that only the areas of the table which are typically relevant to this application have been identified. In the full recirculation mode, the units could provide 4 to 8 air changes of cleansed recirculated air in addition to the 4 to 6 total air changes provided by the ventilation system. THRC units also serve general patient rooms in a partial exhaust mode. In this case, half of the unit's airflow is recirculated back into the room while the other half is exhausted. This exhaust portion could be ducted outside, into a corridor, or through the room's return grill. This would also result in a slightly negative pressure within the room, which would in turn reduce the likelihood of pathogens escaping to surrounding spaces. In order to supplement the room's clean airflow rate by 3 to 5 air changes, the units would have to handle a total of 6 to 10 air changes. This table relates that objective to the THRC unit airflow capacities for the relevant range of patient room volumes. This will also impose a slightly negative pressure upon the room, reducing the risk that contaminants will spill out into the hallways and other adjacent spaces. During pandemic periods, THRC units could be used to temporarily convert standard patient rooms to airborne isolation rooms. These rooms require that a minimum of 12 air changes per hour of exhaust be maintained at all times. As with general patient rooms, Standard 170 prescribes that a minimum of 2 outside air changes passed through a MER 14 filter within the air handling unit be delivered to that room. The total airflow delivery must be maintained sufficiently lower than the exhaust airflow rate to maintain a negative pressure differential of at least 0.01 inches of water between the room and its surrounding spaces. As previously mentioned, general patient rooms are designed for supply and exhaust airflow rates that typically range from 4 to 6 air changes per hour. THRC units can be used to exhaust the additional 6 to 8 air changes required by an AII room. The exhaust is passed through a HEPA filter and can be directed outside as shown or ducted to a surrounding space once it's been cleansed by the room air purifier. This table relates the THRC unit capacities to the applicable exhaust air removal requirements for converting standard patient rooms. In many cases, the exhaust air passing through the THRC unit will be ducted directly through an opening in the outside wall or window. In the event the exhaust air is to be ducted to the room's return grill, all 12 air changes must first pass through the THRC unit before entering the exhaust air duct. Note that the recommended airflow capacities have been derated by approximately 25% to accommodate HEPA filter loading and the potential reduction in exhaust capacity this might cause. The hardest hit population during the COVID-19 pandemic has been the senior citizens in nursing homes and other long-term care facilities. Most of these facilities employ PTAC units that simply recirculate reconditioned room air. Ventilation air is delivered by a separate dedicated outdoor air system to the corridors and larger gathering areas, but not directly into the resident living spaces. Standard 170 prescribes 2 outside air changes for resident living areas and 4 air changes for gathering areas. It does not regulate the amount of room air circulation, which in this case is intermittent and based on the room's conditioning needs. In addition, the DOAS air handling units serving these spaces need only employ MERV 8 filters and will rarely be able to adapt to a filter that is capable of removing small particles like viruses. THRC units can be provided and operated in their full recirculation mode within the resident spaces. This table defines the amount of recirculation air that would be required to achieve equivalent air change rates of 4, 6, or 8 air changes per hour independent of the central ventilation system. Almost any size residential unit could be served by a low-flow unit, providing 4 clean air changes, while additional air changes might require operation of a high-flow unit on low or medium speed, depending upon the size of the residency and the desired rate of clean air recirculation. Of course, gathering areas are often larger than living areas, so this table is expanded to include larger room volumes, which would include areas such as dining and socializing areas. THRC high-flow units could be used to recirculate 4 air changes per hour of clean air to spaces as large as 10,000 cubic feet, increasing the room's effective air change rate to 8 air changes per hour. Larger spaces and higher recirculation rates could be treated by multiple units. In addition to the spaces we've identified, THRC units could also be used to mitigate disease transmission in other healthcare spaces such as emergency rooms and waiting areas, intensive care units, sputum induction procedure rooms, and dialysis centers. Thank you for your attention. Now let's open it up for any questions or comments you might have.